Hey everyone, today I am going to go over flaky tests. This is one of the most commonly asked questions that we get. It's one of the biggest problems that testers face in their automated testing code as testers try to maintain their test suites. So first of all, let's define what flaky means. A lot of people mix up flaky tests with brittle tests or use them interchangeably. They're very different. Flaky tests are tests that currently sometimes fail, intermittent. Sometimes they're passing, sometimes they're failing, and it's not always obvious why. We spend a lot of time as testers trying to figure out, is this failure real? Why is it failing when it shouldn't be failing, when the system's working properly? What things do I need to do to my code to make sure that it doesn't fail in the future? Now, brittle tests, on the other hand, these are just tests that they're not even necessarily failing right now. They are just more likely to fail. This includes things like hard-coded full path XPath, right? If anything changes on the site, anything is added to the DOM, it no longer is going to match that full path, and your tests are going to fail. So it's brittle because it's not resilient. It's not going to be able to handle even small changes. So this is where good locators are important. This is where understanding the context of your site is a redesign likely? Should you be using class names for things? Are class names unique, or some other item with some other element with the same class name going to get added and cause a problem? This is also the same thing with text. Can you rely on the text of the page, or is there going to be, or are you going to have to deal with internationalization? Are you going to have to test multiple different languages with the same site? So understanding the context of your specific site is going to influence quite a bit how brittle your tests might be and the strategies you're going to employ to minimize brittle tests. And the key thing about brittle tests is once they start failing, they're never going to pass again. Something changed. They weren't resilient enough to weather that change. So now they're failing, and you're going to have to go in and adjust the code. And this is where we see like self-healing code come in. These self-healing mechanisms are going to try and predict what changed and where and how to adjust for that. And the concern obviously with any kind of self-healing process is, what if it self-heals to the wrong thing? Are you actually testing the thing you thought you were testing? Or do you have a false sense of confidence because you think you have a test for something that you don't? So you just have to be careful and understand for your context if it's something that makes sense, and understand your risk profile. How important is it that it self-heals versus that you're confident in the tests and the things that you're testing? You need to start with your code in a known state. That state has to be understood, and everything that you're going to be doing in that test starts from a known position. And then everything in your test needs to be non-deterministic, which means you're not checking the URL and taking different actions based on whether you see one locator or see another. You're testing it. You know what flow your site needs in order for you to go through that particular test. Don't complicate it by trying to guess the state of the system, because you're always going to get something wrong in that. I've seen a lot of very clever people write really impressive frameworks that try to do a guessing game with all of this, and there's always a problem. There's always something that gets in the way, and there's no easy fix when there's a problem there. I've also seen a lot of test failures that come intermittently because the CI server that you're using can't handle the load that you're putting on it. Do you have a really small server that you're running, Jenkins or something on, and you're trying to run 100 tests in parallel in Java? It might not have enough power to keep up with all of the different threads and processes you're trying to create. Same thing, the system under test itself. Your website that you're testing against, is your staging environment complicated? Does it have enough? Does it have the right load balancers? Does it have enough processing power? Even tests that are servers that are ephemeral, you deploy it somewhere. Are you deploying it somewhere on AWS or something where it has enough memory, it has enough power, it has enough network capacity to handle running 100 tests against it at the same time? One of the first things I'll tell people when they're seeing a bunch of weird failures when they're running high in parallel, drop it down from 100 to 20. Do you still see those same failures? You do not. That's a good indication that the system that you're running against, or your CI server is not powerful enough to run all those tests. And the last thing, as far as known states go, I've seen a lot of problems over the years with cookies from the previous test getting in the way of the next test, or some kind of caching, some kind of problem, or running multiple browser instances on the same machine, causing problems. Sometimes there are things that just need the browser to be in focus. And if you have multiple browsers on the same machine, they're not going to be in focus, and one of them is going to fail. And this is where a service like Sauce Labs comes in, where they make sure that there is each test gets its own virtual environment with a brand new known state of a browser, a version. All of those things are determined ahead of time, and you can get the same thing every single time you make that request. The next issue with Flaky Tests is independent data. I see a lot of times, especially when running in parallel, you're using the same data, and sometimes one test using that data does one thing, another test does another thing, and the tests will fail when run at the same time. So it's flaky because if you run it in series, it's fine, but when you run it in parallel, it's going to fail. So sometimes passing, sometimes failing. To manage fixtures or static references, you end up having like large spreadsheets where you're tracking which data is associated with which test and how different things can be used, and it can be very complicated. And this is why I recommend, and I've talked about this quite a bit, that this idea of just-in-time data generation. Each of your tests can create all of the data that it needs during the course of the test. And if you have that, it's impossible for two different tests to be using the same data and for one test to fail as a result. So the big thing really is synchronization. For most people, flakiness is synonymous with race conditions. This is the one where we often as testers spend the most time trying to figure out our code. Right? Your code is executing faster than your site is ready for it. And so the code is already on to the next action, even though the site hasn't finished what it needs to do in order to be ready for that next action. And that is one of the most pernicious and difficult things to get right across the board. So there's 4 different approaches to doing synchronization. There are local options and global options. The local options include hard-coding sleeps and doing explicit waits. And then the global option include implicit waits and abstract waits. The first is hard-coded sleeps. Everyone says that's a bad idea. Everyone knows it's a bad idea. There are times when it's easier and faster to do that than anything else. It's still not a good idea, but sometimes it works in the context of what you're doing. The problem is you never know how much either you're sleeping too long or you're not sleeping long enough some of the time. And it's impossible. Either you've got a performance issue or you might have flakiness, and it's really hard to know at what point that becomes an issue. The first global option is an implicit wait. This is something built into Selenium, built into the driver, built into the WebDriver specification, where when you locate an element, instead of erroring immediately, Selenium will wait up until the time of that timeout before it comes back saying couldn't find the element. So if it finds it right away, as soon as it finds it, it returns it, and it's not going to error until that timeout is hit. The problem with implicit waits is that you do not maintain control of the waiting in your code. So if you set a large implicit wait, you lose control in your code. It makes things harder for debugging. It makes explicit waits difficult if you're trying to mix different waiting strategies, sleeps and implicit waits, or any of these other options. Things get a little wonky. So it's just harder to deal with, but it's great. It's one line of code, and you could see a huge difference. So if you're having problems with a lot of flaky tests, try setting a small 1 or 2 second implicit wait. See if that makes a difference. Again, not ideal. It's going to cause other problems. But if that one line makes a difference in your test suite, then give it a shot. So explicit waits, this is the gold standard. This is what everyone tells you to do. This is every single time there might be a race condition, make sure you're waiting for the exact right thing before you take the next action. The problem with explicit waits is it's really hard to know exactly what that is. and also you end up with these explicit weights everywhere in your code. So my proposed solution to all of these, I like the idea of a global solution like an implicit weight, but avoiding the implementation details that are a problem with implicit weights. But I like the control that you get with an explicit weight. So this is a global solution that essentially uses explicit weights under the hood. And the idea is, instead of doing the weighting at the locating phase, which is what an implicit weight does, do the weighting at the action phase. Make sure that the element is available when you click it or send keys. Another big problem a lot of people have come with stale element exceptions. You pretty much have two choices when you're working with elements. You can always locate the element every single time you go to use it, but that is not very performant and comes with a lot of other issues. Or you can cache the element in a variable and use that, but that risks a stale element exception if something on the page has changed, if there's a refresh, or even if something else gets added to the DOM. Sometimes the object in memory that the driver is referencing changes because the DOM itself has moved around in a way that the driver no longer has that object ID associated with that element, and it will give a stale element exception. So the great thing about abstract weights is that it's global. It applies every single time you take an action. I find that this solution solves 80 to 90% of flakiness issues. A lot of the time that there are problems with synchronization, it's a matter of you forgot to put the explicit weight in. You do something like this globally where it's in your framework in one place and it's used everywhere, you make sure that you don't accidentally forget any of these things. This can sometimes be non-performant though if every single time you do anything with an element, it does a locate or it checks if it's enabled. You can have a bunch of, is it there, is it displayed, is it enabled? You can have a bunch of different checks before you take the action, and this is not always performant. So one thing I talk about as far as speeding up some of these things, I call it asking for forgiveness instead of asking for permission. Just click the element, locate it, click it. If it's there, if it works, everything's fine. If it doesn't work, Selenium will let you know. It'll say it's not displayed. It'll say it's stable. You also want to do this by passing in the locator, because then you can relocate it as part of this loop. So it's stale, relocate it. It's not there yet. Keep trying. My approach to doing this is much more complicated than this, but this gives you an idea of a way you can do this. So this is how I look at the ways that we can reduce the number of tests that are sometimes passing and sometimes failing. The more errors that you have to investigate, the harder it is to make sure that you have confidence in the code that you're releasing.